A planet drifts through space, and nothing ever rises above its horizon. No sunrise, no sunset, no bright star crossing the sky, just darkness that never breaks. For most of us, that image should not exist. A planet belongs to a star. That is the arrangement we expect. Planets orbit, stars shine. Day follows night. Then astronomers begin finding planetary-sized objects that are doing none of those things. These worlds are not circling a sun. They are not bound to a host star. They are moving through interstellar space completely alone. Remove the star, and the familiar rhythm of a planet disappears with it. There is no dawn waiting beyond the horizon, no morning arriving tomorrow. The sky remains unchanged, and yet the planet is still there. Yet the planet is still there. The star is gone. The world is not. A planet can continue existing even after the sun is gone, which creates a far stranger reality. If a planet can survive without a star, what happens to it after the last sunrise has already come and gone forever? The planet is still alone. The star is still gone. And the simplest prediction seems obvious. Without sunlight, everything should freeze. The world should become inactive, cold, and effectively finished. For a while, that explanation feels secure. Then researchers begin looking at what a planet may still carry with it after the loss of its star. The star is gone. Yet some of the planet's heat remains. Long after the last sunrise, energy can still be leaking outward from deep below the surface. Radioactive materials continue releasing heat. Internal warmth can remain trapped beneath insulating layers. The sunlight is gone. Not every source of energy is. The frozen ruin people expect is suddenly harder to find. Instead of a world instantly becoming frozen debris, the planet may continue holding pockets of warmth long after its star is gone. The darkness remains. The isolation remains. But the assumption that every process immediately stops becomes harder to defend. The prediction still sounds reasonable. It just no longer fits as cleanly as it did before. Permanent night no longer guarantees a completely dead world. The moment that possibility appears, an option disappears. Rogue planets can no longer be dismissed as simple frozen remnants drifting through space. Some may retain more activity than the darkness alone would suggest, which leads to a larger problem. If these wandering worlds are not automatically lifeless frozen ruins, how many of them might actually be out there? Planetary systems do not always remain orderly. Worlds move around their stars for millions or billions of years, but those arrangements can become unstable. A planet drifts slightly outward, another crosses its path. Gravity begins exchanging momentum back and forth. What starts as an ordinary planetary system can slowly turn into a contest of competing poles. One planet gains speed. Its orbit stretches farther from the star. Another close encounter follows, then another. Each interaction changes the path again. Eventually, a planet can be pushed so far outward that it never returns. The star is still there. The planetary system survives, but one member has been thrown away. Suddenly, rogue planets stop looking impossible. They do not have to begin as strange objects formed in isolation. They can emerge from familiar systems, going through familiar gravitational interactions. A stable arrangement becomes unstable. A planet is scattered outward. The star loses a world. Nothing about the idea feels unusual anymore. Rogue planets start to look less like impossible cosmic accidents and more like rare outcasts. Worlds that once belonged somewhere before being permanently expelled into interstellar space. And if that process happens naturally, even occasionally, there is an obvious question left to answer. Do observations actually support the idea that these worlds are only rare exceptions? The explanation feels solid. For the first time, the mystery appears to be shrinking. Planets can be thrown out of their systems. Rogue planets are the survivors of those ejections. Strange, but understandable. Then astronomers begin looking for them. That turns out to be a problem. A rogue planet produces very little light of its own. Most of the time, it drifts through darkness, almost completely invisible. A telescope can stare directly toward one and never know it is there. So researchers watch distant stars instead. Occasionally, a hidden object passes between Earth and a background star. For a brief moment, gravity bends and distorts the starlight. The star brightens, then returns to normal. The unseen object moves on. The event is temporary. The evidence is not. Survey after survey begins uncovering more rogue planet candidates than the comfortable explanation seems prepared for. At first, that is easy to ignore. A handful of detections does not change much. Then more appear. Then more. Rare worlds should appear occasionally. The observations keep arriving anyway. A few detections fit the picture. Rare worlds should appear occasionally. But the observations keep arriving. Every new detection pushes against the same idea. If rogue planets are only uncommon outcasts, then the hidden population should remain limited. Instead, the growing evidence repeatedly points in the opposite direction. Nobody needs a new theory to create the problem. The problem keeps arriving on its own. The idea that planets normally spend their lives attached to stars begins losing its certainty. More and more worlds seem to be emerging from the darkness without any visible star nearby. And because these objects are so difficult to detect in the first place, an uncomfortable possibility appears. Humanity may be seeing only a fraction of what is actually moving through the galaxy. The search continues, but the planets themselves remain hidden. Most rogue planets do not announce their presence. They do not shine like stars. They do not produce an obvious signal that can be tracked across the galaxy. For long stretches of time, they move through darkness completely unnoticed. Astronomers usually detect them indirectly. A distant star briefly changes brightness. Gravity bends the starlight for a short time. The distortion appears, then disappears. The hidden object is gone again. The signal disappears. The object disappears. Only the evidence remains. That limitation creates the final consequence. The planetary worlds that are easiest to find are usually attached to stars. Their stars reveal them. Their stars give astronomers something to watch. Rogue planets offer no such advantage. They spend their existence between the stars, and many may pass through the galaxy without ever becoming directly visible to us. The lonely world from the beginning no longer looks like an isolated curiosity. It becomes part of a larger possibility. Humanity's catalog of planets is built largely from the worlds we can easily see. Those worlds orbit stars. Their stars reveal them. Rogue planets offer no such advantage. They move through the darkness between stars where ordinary observation rarely reaches. Our inventory may be incomplete, not because the worlds are absent, because the planets easiest to find are the ones orbiting stars. The hidden ones may spend their entire existence moving through darkness without ever revealing themselves at all.